Hey y'all, we're going to do notes today over angular and linear velocity. So let's start with linear velocity. Linear velocity is the rate of change of an object's position with respect to time. So I've added this extra little bit here just to kind of maybe help us understand it better. It's how fast a dot is moving along the circumference of a circle. So if you think about a circle and you're thinking about a dot that might be moving around a circle, you're talking about like a fraction of the circle's circumference. And so back in geometry, we kind of learned that arc length represented that fraction of the circle's circumference. And we would have done the angle measure divided by 360. That represents the fraction of the circle's degrees that we're talking about. And then you multiply that times the circumference, which that formula was 2 pi r. Well, now that we are a little more familiar with radians, this 360 degrees right here, it would be a lot easier for us to, instead of say 2 pi. And then if you'll notice, if you have theta over 2 pi and you're multiplying that times 2 pi r, these 2 pi's are going to cancel out and you're just left with theta times r. So that's what arc length is. It's the angle times the radius as long as that angle is in radians. All right, so we learned that a little bit a couple of classes ago, but just as a reminder. So then when you do linear velocity, you're talking about the arc length with respect to time. So when we do our formula, we'll do theta times r divided by time. All right, let's do a few examples. Okay, so a Ferris wheel rotates 3 times each minute. So you're going to go in a circle 3 times in a minute. So if you think about that, if I can make my pen right, sorry. That means you're going to go 3 full circles in 1 minute. And remember that a full circle is 2 pi if we're talking about radians, and we're going to do that 3 times. So we're going to do 3 times 2 pi, which is 6 pi. So that's going to be my rate, my angle, my theta. So right now we know we've got theta equals 6 pi. We know that we're going to do that in a minute, and so our time is equal to 1 minute. All right, the passengers sit in seats that are 24 feet from the center of the Ferris wheel. So if you think about a Ferris wheel, that looks like a balloon, not a Ferris wheel. Sorry, I don't know how to make a Ferris wheel. I do know we have seats on here. Well, those seats, they are about 24 feet from the center. And so that's our radius. So my radius equals 24 feet. All right, what is the linear velocity of the passengers in the seats in feet per second? So we need to pay attention to our units a whole lot on this particular lesson. So instead of measuring my time in minutes, I need to measure it in seconds. So 1 minute is the same thing as 60 seconds. So when I use my linear velocity formula and I plug in my numbers, I'm going to say for theta 6 pi because I've gone 3 full circles. My radius was 24 feet. My time is going to be 60 seconds. So when you simplify that, basically 6 goes into this 10 times, so it cancels here. And then that becomes 12 and 5. So that ends up being 12 pi over 5, and then my units are feet per second. So that's an exact answer. If you were to get a decimal, it would be 7.539 feet per second. All right, let's move on to example 2. Okay, in example 2, we have a phonograph record. It's turning at 45 revolutions per minute. That means it makes 45 circles in 1 minute. So your theta, you've gone 45 full circles, so 45 times 2 pi tells me my theta is 90 pi. All right, and then we do that in 1 minute, so my time equals 1 minute. If the distance from the center of the record to a point on the edge of the record is 3 inches, that would be my radius. Find the linear velocity of the point in feet per minute. So this time I need, instead of inches, I need feet. And I need minutes, which I wrote this in minutes, so we're good there. But I do need to convert 3 inches to feet. So when you're converting 3 inches to feet, you need your units to have feet in them, not inches. So you need to think about how many feet there are, how many inches there are in feet when we have 12 inches in 1 foot. This way, whenever I'm multiplying, my inches will cancel out, and I'll end up with a unit of feet. So we end up with 3 over 12, which simplifies to be 1/4. So that's 1/4 of a foot. That's what 3 inches is. All right, using your formula for linear velocity, we do theta times r divided by time. My theta is 90 pi. My radius is 1/4 feet. And then over time, I'm doing that in 1 minute. Okay, so if you multiply that out, you're going to do 90 times 1/4, which is about 22.5 pi, and then that's feet per minute. Or if you got a total decimal by multiplying pi into the answer, you'd get 70.685 feet per minute. All right, let's do another one. All right, actually we're going to talk about angular velocity now. So let's suppose you have these 2 gears. And I mean, think about how they're going to be turning around, and they have to, each little cog has to mesh up. So these 2 gears must have the same linear velocity in order for them to work, but they are turning at different speeds. The smaller gear will complete more rotations in a given time period than the larger gear. This means they have different angular velocities. So we have the definition of angular velocity down here. The angular velocity of a particle traveling on a circle path is speed at which the angle of rotation is changing. So this time you're going to do the angle divided by time. And we usually use the letter W to represent angular velocity. And so this would be my formula for angular velocity. All right, so I want you to think about, let me move this up a little bit. What I want you to think about is how we talked about linear velocity was theta times r divided by time. Well, up here we have angular velocity is theta divided by time, which if you'll notice, that's this part of linear velocity. So we can rewrite linear velocity as angular velocity times the radius. So linear velocity is the same thing as angular velocity times the radius. And sometimes that formula might help you more based on the information you've been given. So just another formula for you to have. All right, so example 3, the Earth rotates on an axis once every 24 hours. So that's 1 full circle. So that makes theta equal to 2 pi, because the full circle is 2 pi. And you do that in 24 hours. So my time is 24 hours. Okay, what is the Earth's angular velocity in radians per hour? And so we have our angle in radians. We have our time in hours, so we don't have to do any conversion of units. My angular velocity formula is theta divided by time. So plugging that in, we have 2 pi over 24, and that equals, when you simplify it, pi over 12. So that means my angular velocity is pi over 12 radians per hour. Or if you had gotten a decimal, that would have been 0.261 radians per hour. Okay, let's do another example. Okay, on the next example, we have the diameter of a clock is 20 inches. So that makes the radius equal to 10 inches. Okay, find the angular and linear velocity of the minute hand. So if you think about a clock, and when you're doing or thinking about the minute hand, it makes a full circle. So theta will equal 2 pi, and it will take it a full 60 minutes for that minute hand to go around the clock 1 time. They are wanting, let's see, it says here the time should be given in seconds. So I need to convert this minutes to seconds. Well, if I need to get rid of the minutes and make it seconds, I know that we have 60 seconds in 1 minute. So that's the same thing as 3,600 seconds. Okay, if I want to find my angular velocity first, that's going to be theta divided by time. Theta is 2 pi, that's 1 full circle, and that happens in 3600 seconds. So when you simplify that, you get pi over 1800 radians per second. If you had gotten a decimal, it would have been 0.001 radians per second. All right, now that found the angular velocity, we still need to find linear velocity. And since we already have angular velocity, I'm going to use the second formula we figured out, which was angular velocity times the radius. So that's going to be pi over 1800 times your radius, which is 10. So that ends up simplifying to be pi over 180 inches, or I'm sorry, it is in inches per second. All right, so that's your linear velocity, and we've got our angular velocity as well. Let's do another example. Okay, this next page is starting with some practice problems. So you might want to do these practice problems on your own and then just check your answers with us, or you can listen to me walk through them. All right, what's in this little box right here is just it's kind of a good example of explaining the difference between angular and linear velocity. So on a merry-go-round, no matter where you stand, your angular velocity will be the same, but the further you are from the center, the faster your linear velocity will be. So this next problem, it has you mainly just understanding what angle you're talking about whenever we talk about revolutions. So the number of revolutions made by a figure skater for each type of axel jump is given. Determine the measure, the angle generated as the skater performs each jump. Give the answer in both degrees and radians. So if you do a single axel, that's 1.5 revolutions. That means you turned 1.5 circles. And so you're going to do 1.5 times a full circle, which is 2 pi, and that's going to equal 1.5 is the same thing as 3 halves times 2 pi. The 2's cancel, so that's the same thing as 3 pi radians. If I wanted to convert that to 2 degrees, I could just basically replace the pi with 180, and you get 540 degrees. So both of those are answers for that one. If you do a double axle, you're going to turn 2.5 revolutions, so multiply that by a full circle. And so you end up with 5 halves times 2 pi, which would be 5 pi. Okay, on the next one, we're going to do a triple axle. That's 3.5 revolutions, so 3.5 times 2 pi, or 7 halves times 2 pi. So that gives me 7 pi radians. And then if I convert that to degrees, it would be 1,260 degrees. I forgot to convert this to degrees, so 5 times 180, or 5 times pi, is the same thing as 900 degrees. Okay, let's do some more examples. Okay, on the next example, we're going to talk about a satellite in a circular orbit 1,250 kilometers above the Earth. And it makes 1 complete revolution, so that's 1 circle. That's just 2 pi every 110 minutes. What is its linear speed? Assume that Earth is a sphere of radius 6,400 kilometers. So if you think about your radius from the center of the Earth, you go out 1,250 plus that 640. That's the radius from the center of the Earth for the satellite. So adding those together, I get 7,650. All right, theta, because I go in a full circle, would be 2 pi. And then our time, they told me, was 110 minutes. All right, we are looking for linear speed. So that formula is L. And then we're going to, you can use either formula, obviously, but you would have to calculate the angular to make this one work a different way. So my theta is 2 pi. My radius is 7650. And my time is going to be 110 minutes. Okay, so working all of that out, we end up with 1,530 pi over 11. Or we could also say 436.967. And and that would be kilometers per minute. All right, let's do another example. We have a circular blade on a saw that has a diameter of 7.5 inches, and it rotates 2,400 revolutions per minute. Okay, so my diameter is 7.5, which makes my radius half of that, so it'll be 3.75. My theta, if I'm going to do 2,400 revolutions in 1 minute, so multiply that times 2 pi, I get 4,800 pi. Okay, so let's calculate this now. We're trying to figure out our angular speed, which is theta divided by time. My theta is 4,800 pi. And my time is, we're going to do it in seconds. So we know that this happens per minute. So that's the same thing as 60 seconds. All right, so working that out, 60 goes into 4,800 80 times. So that's 80 pi. And then the radians per second. Okay, let's do another example. So find the linear speed of the saw teeth in feet per second as they contact the wood being cut. So we said linear speed was the same thing as omega times the radius. We got the angular speed was 80 pi. We know our radius from up here, it's 3.75. All right, multiplying that out, we end up with, let's see. I just realized I made a mistake. Sorry about that. So when we did our radius up here, our radius was measured in inches. And so here they're asking me to do it in feet per second. So I have to do that conversion. I know that my radius is 3.75 inches. So I need to convert that. I need the inches to go away, and I need it to be replaced with feet. So there are 12 inches in 1 foot, and when you work that out, you end up getting a radius of 0.3125. Okay, so instead of what I wrote right here, I'm going to do 80 pi times 0.3125. And then multiply that out. So you get 25 pi feet per second. All right. Or if you had changed that to a decimal, it would have been 78.539 feet per second. All right, let's do the next one. Okay, on this next example, we have the minute hand of a watch is 1.3 centimeters long. So think about the face of a watch and you've got your minute hand. It's 1.3 centimeters long. What is the linear velocity in centimeters per second? So a minute hand will go around one full circle. It has its radius, which is 1.3 centimeters. Let's see, what else do we need? Our time, it takes it 1 minute to go around. So 1 minute. Okay, on this problem, let's see, what does it say? It wants us to do it in centimeters per second. So we've got to change our minute to be 60 seconds. Oh, you know what? Now we're talking about a minute hand. For it to go around a full circle, I lied to you, I'm sorry. That is actually, it takes you 60 minutes to do that. So when you multiply that times, when you try to get rid of the minutes and get seconds into the problem, it takes you 60 seconds to be 1 minute. So 60 minutes is the same thing as 3,600 seconds. All right, when we do our formula, we're trying to find the linear velocity. So we're going to do theta times r divided by time. Theta is 2 pi, my radius is 1.3, my time is 3,600. All right, on this one, I'm just going to get a decimal, and it ends up being 0.002 centimeters per second. Okay, let's do example 5. Okay, on this one, we have a toy racing car It's traveling around a circular track that's 3.2 meters in diameter. So the radius is 1.6 meters. It's traveling at 0.31 radians per second. So this right here represents your angular velocity. So our angular velocity is 0.31 radians per second. And I know that because of the units right there. So it says find its angular velocity in degrees per minute. So we've got 0.31 radians per second. I need to get rid of the seconds. And so I need seconds to be on top. That way they'll cancel. There are 60 seconds in 1 minute. So that'll take care of the minutes part of the units. Now I need to change radians to degrees. So if I need to get rid of radians and get degrees, I know that there are 180 degrees in pi radians. So multiplying that all out, you're going to get 1065.701 degrees per minute. So let me write that better, sorry. 1065.701, and that's degrees per minute. All right, now it's asking me to find its linear velocity in kilometers per hour. So if I'm going to find the linear velocity, I'm going to use the angular velocity times the radius. So we've got our angular velocity is 0.31 radians per second. So I need it to be in hours. So first I know that there are 60 seconds in 1 minute. That way my seconds will cancel out. I know there are 60 minutes in 1 hour. That way my minutes will cancel out, and I'll have units with the hours in the denominator. I need, let's see, my radius, I have to multiply that angular velocity times the radius, which is 1.6 meters. So we'll do that 1.6 meters. Let me erase this over here. Sorry about that. So 1.6 meters, we need to change meters to be in kilometers. And so 1 kilometer is the same thing as 1,000 meters. All right, so that should take care of everything. Remember, you multiply everything in the numerators together and everything in the denominators together. Actually, everything in our denominator is 1 except for that 1,000. So when you type that in your calculator, you're going to get 1.785 kilometers per hour. Okay. Oops. All right, on the next example, we have determined the angular velocity in radians per second of a wheel that's turning 350 RPM stands for revolutions per minute. So that means that your theta, you're doing 350 full circles in 1 minute. So we're going to do 350 times 2 pi to figure out our angle. That's 700 pi radians. Okay, so that's, we also need our time. We're told that we do 350 revolutions per minute, so my time is 1 minute. And we need it to be in seconds, so that's the same thing as 60 seconds. All right, so angular velocity equals theta divided by time. So 700 pi divided by 60 seconds. And that's going to equal 70 pi over 6. That would be an exact answer. Or, I'm sorry, that would actually simplify to be 35 pi over 3. And as a decimal, that would be 36.651. Again, that's radians per second. Okay, let's do another example. Okay, on number 7, we have a Ferris wheel with a diameter of 220 feet. So that means your radius is 110 feet. And it takes 42 seconds to rotate once. So one full rotation is 2 pi And the time it takes it to do that is 42 seconds. Okay, to determine the angular velocity, so angular velocity is theta divided by time in radians per second. So we've got our angle measure in radians and we've got our time in seconds, so we're good as far as that goes. So we're going to do 2 pi divided by 42. Okay, so when we type that into, well, first let's just simplify. That's pi over 21 radians per second. And again, if you type that into your calculator, you're going to get a 0.149 radians per second. All right, now we're going to determine the linear velocity in feet per second of the Ferris wheel. So we've got our radius in 110 feet. That's good. And we've got our time in seconds. So linear velocity is angular velocity times the radius. So my angular velocity we just figured out. I'm going to use the exact answer first. So we'll say pi over 21, and you're going to multiply that times the radius, which is 110. Okay, so that ends up, when you type that in your calculator, you're going to get 16.455 feet per second. And that's your linear velocity for that. On number 8, what is the angular velocity in radians per minute of a notch on a wheel that takes 24 rotations? That's 24 full circles per second. So your theta, you go around a circle 24 times. So that's an angle measure of 48 pi. The time it takes you to do that is 1 second. And we need to know what it is per minute. So remember, if we want to convert that, if we want seconds to go away, so it goes down the bottom, and we've got 60 seconds in 1 minute. All right, that way your seconds go away. So we're talking 1/60th of a minute. Okay, so let's see. We are going to try to find angular velocity, which is theta divided by time. So 48 pi divided by 1/60th. Okay, so if you'll think about that, you're doing, if you do 48 pi divided by 1/60th, that's the same thing as saying 48 pi times 60 over 1. So that ends up multiplying out to be 2,880 pi radians per minute. And you could get a decimal on that as well. Okay. On number 9, a flywheel mounted on an engine crankshaft has a radius of 6 inches. If the engine is running at 2,800 RPM, that's revolutions per minute. That means that you're going to turn 2,800 times. So you multiply that times 2 pi, and you get 5,600 pi. That's your angle measure. What is the linear velocity at a point on the outer edge of the flywheel? And we want it in feet per second. So we're going to have to change those 6 inches to feet. There are 12 inches in 1 foot. That way your inches cancel out. So you end up with 1/2 of a foot. That's what your radius is. Okay, so finding linear velocity, we're going to do theta times r divided by time. We don't have the angular velocity this time, so we need to use this formula. So theta is 5,600 pi times my radius, which is 1/2 of a foot, over time. I forgot to write that, but we went revolutions per minute, and we need our time to be in seconds, so we're going to say 60 seconds. Okay, multiplying all of that out, we're going to end up getting 140 pi over 3 feet per second. And that as a decimal would be 146.607 feet per second. All right, on number 10, we have dandruff and elephant are riding on a Ferris wheel. Dan observes that it takes 20 seconds to make a complete revolution. The seat is 25 feet from the axle of the wheel. What is your angular velocity in radians per minute? So we know our radius is 25 feet. That's really not needed for angular velocity. But it takes 20 seconds to make one full revolution. So theta is 2 pi because we go one revolution. And the time it takes me to do that is 20 seconds. We need that to be in minutes, so I'm going to multiply that like this to get rid of seconds. And that gives me 1/3 of a minute. Okay, so let's see, we'll say our angular velocity is theta divided by time. So theta is 2 pi divided by 1/3. So remember 2 pi divided by 1/3 is the same thing as 2 pi times 3/1, which ends up being 6 pi. And those are radians per minute. So that's your angular velocity. Now we need to know what the linear velocity is in yards per minute. So linear velocity formula is your angular velocity times the radius. So we figured out our angular velocity was 6 pi radians per minute. So we've got the right units for time. We're going to multiply that times our radius, which is 6 inches. But we need that to be in yards. So right now I know that there are 12 inches in 1 foot. That way my inches cancel out. I know that there are 3 feet in 1 yard. So my feet will cancel out. And when I multiply straight across, I'll do 6 pi times 6. I get 36 pi on top. And on the bottom, you'll end up with 36 as well. So that ends up simplifying to be pi yards per minute. Okay, I'm sorry. I'm just now looking back over that, and I'm realizing that I used the radius from number 9 instead of the radius from number 10. So let me rework that one. Sorry about that. Okay, so your angular velocity we figured out was right here, 6 pi radians per minute. Okay, now we're going to multiply that times our radius, which is actually 25 feet. And so we need to not have feet, we need to have yards, and there are 3 feet in 1 yard. So the feet cancel out. And when you multiply straight across, 6 times 25 is 150 pi. And then on the bottom, we have 3. And so that simplifies to be 50 pi. And our units are yards per minute. And that's my answer. Sorry about that. And if you wanted to convert that to a decimal, you would get 157.079 yards per minute. Okay, so again, it's always a good idea to just kind of look back over it. You might catch your mistakes somehow, like I just did. Okay, those are all of our examples for angular and linear velocity. You have some homework you can try now. Thanks.